Welcome to 10 Minute CS. For one, different ways to add parentheses. So we are given a string of expressions here which has some numerics and some mathematical operators. We have to find all the outputs which we can make after applying parentheses to this expression. So there could be multiple ways to add the parentheses here. As we can see, we can either have parentheses over 2 and 1 or between the expression 1 minus 1. For both of these we are getting different answers. One is 0 and other is 2. We have to return all of these answers, and the answers can be in any order. So let's analyze this expression. 2 into 3 minus 4 into 5. So one way is we can either split the string at the first multiple and can compute our expression from 3 till the last, and then can multiply the computed answer with our 2 to get the answer. The other way is we don't split it 2 but we split it the other minus. So we compute this expression first and the other one, and then minus subtract it to get our answer. And similarly we can have multiple ways to do it. So we see here, for every operator we can either split over there or just skip it and move it to the next one. So definitely we have to run a for loop over this, and we have to check for the operator and decide whether we want to split it or to move on to the other one. And we have to compute the answer for all the possible ways, so we have to get the answer for both of them. Now let's look at the constraints. The constraints are not that high. The expression length will be within the range of 1 till 20, and the expressions can be addition, subtraction and multiplication only. And all the integer values are from 0 to 99. One thing to note here, there are no leading minus and plus signs denoting that the numbers are negative or positive. We have them in the range of 0 to 99. That means all of the integers will be positive. This makes our problem little less tricky. Now let's move in to how we are gonna compute it. So as said earlier, we will be looping over our expression, and for each of the operator we will be getting, we need to split over there. Let's see, we decide to split at the first multiplication. So we can go to our left tree and our right tree. In our left tree we just have an integer, so we will be returning just 2 from here. And in our right tree we have the rest of the expression, and we decide to split our string at the first negative. So we go to our left tree, which is just the 3, and we return 3 from here. And we go to our right tree, we have 4 into 5. Similarly, now we have another operator, we split and then we return it. While returning whatever answer we get, we have to apply the operator over those answers. 4 into 5 we get 20, and then 3 minus 20 will be minus 17, and minus 17 into 2 will be minus 34. Now the other way will be, instead of splitting over the first one, we decide to split at the next operator. So for this one we will be having in our left tree as 2 into 3 and in right 4 into 5, and we will be getting from here as 2 and 3. We apply the operator into, so we got 6, we return 6 from here. Similarly we get 4 and 5 from these sides, and 4 5 we get 20, and then we subtract. So 6 minus 20 will be minus 14. Now let's look at the other tree. Here we decide to split at the first multiplication, but in the rest of the expression, instead of the first negative, we decide to split at the other multiplication. And then we go to our tree and compute the answers. So we see here the expression here and here will be same. So from our right tree we will be getting multiple answers, right? So let's say we start a recursion from this one, and we have called our recursion for the right tree, and for this one we are getting a different answer, but if we approach it with a different way, we get different answer. So in such a scenario, our answers will be a list, not just a single integer, right? So how much we'll be getting from here? 3 and 4, minus 1 from this side, and 5, which is minus 5. And here we got 4 into 5, 20, minus 17, right? And from our right side we got 2. To get the final answer, we have to multiply the 2 with all of them. So in our recursion, we will be having another for loop, which is to compute all these answers. So this 2 will be multiplied by 5 and this 2 will be multiplied by minus 17 to get the expressions of minus 10 and minus 34. Similarly, we will be having our other trees also, this one. So we decide to split over the other multiplication, and then we go into a tree, compute the answer from here and here. This side we will be having 5, and this side, let's say we had x, and from similarly we had the same expression but a different answer if we decide to compute it in a different way. So let's say we had 5 here, so this x comma 5 will be multiplied with 5, and we will be having our answers as minus 10 and 10. So these are all the trees that we need to compute. So what we saw, we need to traverse over the string using our first for loop, and in that for loop we have to go to our left and right tree, and whatever answer we are getting from them, we have to multiply all those answers, or not exactly multiply, we have to operate our operator over them, over those answers. Let's say for this one it was multiplication, for this one it was also multiplication, for this one it was subtraction. So we have to apply our operator, and then we get our answer list basically. So let's look at the code. We have a helper function. We will be passing our input to it, and our input is the string itself. We will be having our list of resultant, and we will be going through a for loop, and we will check for the operators. If we get the operator, we will split our string till the operator, and then from the operator till the last one. So what I'm saying here is, let's say this is first index, so our first string will be till 2 and the other one will be I plus 1 to till the last. Our substring operation works in such a way that it doesn't take into the account the last index, right? So this will be only 2 and this will be 3 till the last one. So we have got our substrings. We will go to our recursion call, and then whatever answers we will be getting, which will be list again, we will run for loops over them, and we will be computing our answers based on the operator which is falling between these two, and then finally add it to our resultant. Now this is the case when we just have the integer. Now we don't have an operator here, so definitely after running through this for loop, our resultant will be empty. Now in this case, if it's empty, then we need to add the integer value itself, right? So we will be adding integer value of the input, and finally we'll be returning the resultant. Now let's submit it. Yeah, indeed it passed. So what will be the time and space complexity for it? Time complexity, we see that for each operator we are dividing the string into two parts. So definitely it's 2 raised to the power n, and within that we are doing operations over two strings, and we have a double for loop, so it will be into n square. This will be the overall time complexity, and space complexity will be 2 into n due to recursion stack. Thank you for watching.